One line changed in a set of construction drawings. A single steel rod that was supposed to run straight down became two shorter rods, stacked one below the other. On paper, it looked like nothing. A small adjustment, the kind of practical change that gets made on a building site without a second thought. But that one change quietly doubled the force landing on the single connection least able to survive it. Let me show you exactly how that happened. First, you have to picture the space. Inside the atrium of the Hyatt Regency in Kansas City, 3 walkways cross the open air, hung in place like indoor bridges with nothing but floor far below them. One at the second story, one at the third, one at the fourth. 2 of them are the ones that matter, because they lined up. The 4th floor walkway ran directly above the 2nd floor walkway. The 3rd floor span sat off to one side. So if you stood on the 2nd floor walkway and looked straight up, you'd see the 4th floor walkway hanging right over your head. Now, the original plan for holding all of this up was clean. Long steel rods would hang from the roof framing and drop straight down. Each rod would pass through the 4th floor walkway and keep going, all the way down through the 2nd floor walkway below. One continuous rod, threading through both levels. And here's the part that matters. The 4th floor walkway gripped that rod at its own level, while the 2nd floor walkway gripped the same rod lower down. The weight of the lower walkway hung near the bottom of the rod and was carried straight up the steel to the roof. It never leaned on the 4th floor at all. So the 4th floor connection only ever had to hold one thing, the 4th floor walkway. Each level carried its own weight. That was the drawing. What actually got built was different. Instead of one rod running the full height, construction used 2. One set of rods ran from the roof down to the 4th floor walkway and stopped there. Then a second, separate set of rods began at the 4th floor walkway and dropped down to the 2nd floor walkway beneath it. The continuous thread was cut in the middle, right at the 4th floor. So follow the weight now. The 2nd floor walkway still had to hang from something, but its rods no longer reached the roof. They stopped at the 4th floor walkway, which means the entire weight of the lower walkway now pulled down on the 4th floor structure, and the 4th floor walkway was already hanging its own weight on the very same connection. One connection, suddenly holding 2 walkways. The force it had to carry essentially doubled. Nothing in the room looked any different. The rods were the same thickness, the walkways hung at the same heights. But the path the load traveled had been quietly rerouted, and a connection that used to do the work of one was now doing the work of 2. And here's where it goes from bad to worse. You might assume that connection had strength to spare, that doubling its load simply ate into a comfortable safety margin. It didn't. When investigators went back and studied the original design, the one drawn on the approved plans, they found that even that version, the continuous rod version, before anyone changed a single thing, did not meet the building code. The connection holding these walkways up was underbuilt from the very start. There was no comfortable margin to lose. So the construction change didn't ruin a sound design. It took a design that was already too weak and shoved it past the edge. The numbers make that drop impossible to wave away. By the investigators' estimate, the original continuous rod arrangement would have provided only about 60% of the capacity the code called for, already short of the mark. The arrangement that was actually built came out to roughly 31% of that required capacity, measured against the load sitting on it near the end. Sit with that for a second. This was a connection left with less than a third of the strength it was supposed to have, with almost nothing in reserve. It was no longer a question of whether it would fail. It was only a question of when and of how much weight it would take to get there. Then came July 17, 1981. The walkways were crowded, heavy with people, and the weakest point gave first. From the way the steel had deformed, investigators traced the beginning of the failure to a single connection, the one on the east end of the middle box beam of the 4th floor walkway, the very connection that was now carrying 2 walkways instead of 1. When it let go, the 4th floor walkway dropped. And because the 2nd floor walkway was hanging directly from it, the lower walkway came down with it. The 2 of them fell into the atrium together, straight down the vertical line where the geometry had stacked them all along. When the final count came in, 114 people had been killed, and 186 more were injured. And this is the part worth sitting with. There was nothing mysterious about it. No hidden flaw in the steel itself. No act of God. No freak stroke of bad luck that no one could have anticipated. The walkways came down because a connection that was already too weak was asked to carry twice the load it was ever meant to hold. And the thing that doubled that load wasn't a storm or some unimaginable crowd. It was a change on a drawing. One continuous rod became 2. On paper, it looked like a threading detail, a minor convenience. In the steel, it rerouted the entire path of the weight and dropped it onto the one point least able to bear it, cutting a margin that started at only 60% of what was required down to about 31%, and then waiting for a crowd to arrive. The tiny drawing change was only tiny on the page. In that atrium, it was the whole difference between standing and falling.